Welcome viewers. In this video, the two-port network, under two-port network, expression of Z parameter in terms of Y parameters and vice versa. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In the two-port network, we are going to express Z parameters in terms of Y parameter in terms of Z parameters. That is coming under two-port network. Now first we will see what is Z parameter, what is Y parameter. Z parameter is nothing but open circuit impedance parameters. Y parameter is short circuit admittance parameters. The separate video available for Z parameter and Y parameter. Link is available in the description box. So the equation is for open circuit impedance Z parameter. The general equation is V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. We'll take this equation number 1 and 2. This Z11, Z12, Z21, Z22 are impedance parameters, Z parameters. Here voltage, input and output voltage are expressed in terms of input and output current I1, I2. Voltage is expressed in terms of current. In case of short circuit admittance Y parameter, the equations are I1 equal to Y11 V1 plus Y12 V2. Similarly, I2 equal to Y21 V1 plus Y22 V2. This Y11, Y12, Y21, Y22 are admittance Y parameters. Here input and output current are expressed in terms of input and output voltage. Currents are expressed in terms of voltage. Right? Here output open circuit means the output port is open circuited. Here output port is short circuited. Right. So take this equation number 3 and 4. So we have 4 equations are there. Now we'll see how to express Z parameter in terms of Y parameter and Y parameter in terms of Z parameters. Now we'll see the procedure. So from equation 1, 2, 3 and 4, it is easy to derive the relation between open circuit impedance parameters and short circuit admittance parameter by means of two matrix equation of the respective parameters. Right? So from the matrix we can easily express. So the first step, by solving equation 1 and 2 for I1 and I2 we will get. So we are going to solve the equation 1 and 2, that is open circuit impedance parameters, that is for I1 and I2. So while solving, what we got, this I1 equal to V1 Z12 V2 Z22 divided by del Z, and I2 equal to Z11 V1 Z21 V2 divided by del Z. So this del Z is nothing but determinant of the Z matrix. What is Z matrix? Z11, Z12, Z21, Z22. Right? So the equation 1 and 2 is solved for I1 and I2. We got the expression for I1 and I2. In that delta Z is this determinant of the Z matrix. Now we can expand this. So we can find the this determinant. By finding the determinant, we can able to find the I1. What is determinant? We have to cross multiply these two minus these two parameters, so that we'll get the I1. So V1 into Z22, V1 into Z22 divided by del Z minus Z12 into V2, Z12 into V2 divided by del Z. Right? So from this matrix we got the equation for current I1. This equation, take equation number 5. What we are doing, the normal determinant of 2 cross 2 matrix. These two parameters are multiplied minus these two parameters divided by del Z. Similarly I2, Z11 into V2, Z11 into V2 into divided by del Z minus Z21 into V1 divided by del Z. Right? So this is the first term, this is the second term, minus. So take this equation number 6. Right? So in order to express V1, V2, these two terms are interchanged. Right, now we got the expression for I1 and I2. Take this equation number 5 and 6. Now we are going to compare this equation. Now we are going to compare equation 3 and 4 with equation 5 and 6. This is equation 5 and 6. That we are going to compare with 3 and 4. I wrote the equation 3 and 4 again. That is a short circuit admittance parameter equation 3 and 4, 5 and 6. See, both are similar. This I1 currents are expressed in terms of voltage here also. So I1 equal to Z22 divided by del Z into V1. So here also same thing. I1 equal to Y11 into V1. So while comparing these two equations, this coefficient of V1 is nothing but Y11. That is equal to Z22 divided by del Z. Right? We are comparing the coefficient of V1 as well as V2. So by comparing these two, it is clear that Y11 equal to Z22 divided by del Z. So it is written separately. Y11 is Z22 divided by del Z. So that Y parameter is written in terms of Z parameter. Similarly, Y12 is nothing but minus Z12 divided by del Z. So Y12 equal to minus Z12 divided by del Z. Similarly, equation 4 and 6. Y21 is nothing but minus Z21 by del Z. Say other parameters are equal, so that these two coefficients are equal. So Y21 equal to minus Z21 divided by del Z. Then Y22 is Z11 divided by del Z. That is written here. So by comparing these 3 and 4 and 5 and 6, by comparing this coefficient, we can express the Y parameters in terms of Z parameter. So this is the 4 equations available. Y parameter in terms of Z parameter. Now we'll see the Z parameter in terms of Y parameter in the next step. So in a similar manner, Z parameter may be expressed in terms of admittance parameter by solving equation 3 and 4. Earlier we solved equation 1 and 2. Now equation 3 and 4 for voltage V1 and V2. So earlier we solved equation 1 and 2 for current. Now solving equation 3 and 4 for voltage. What we got? V1 equal to determinant of I1, Y12, I2, Y22 divided by del Y. Similarly, V2 equal to Y11, I1, Y21, I2 divided by del Y. This del Y is nothing but determinant of the Y matrix, that is Y11, Y12, Y21, Y22. Right. So by expressing this, by expanding this V1 and V2, we got the equation 7 and 8. What is that? I1 into Y22 divided by del Z, del Y. I1 into Y22 divided by del Y minus these two. You have to multiply these two. Y12 into I2, Y12 into I2 divided by del Y. Right. Similarly here, Y11 into I2 divided by del Y. Y11 into I2 divided by del Y. So second term is written here. First term is written second. Right. Then minus. So this minus I1 into Y21 divided by del Y. Right. So these terms are interchanged in order to bring the uniform I1, I2. Right. So by expanding this determinant, we are able to get the equation of V1 and V2. Now we are going to compare this with the equation 1 and 2. Take this equation 7 and 8. So what we got is termed as 7 and 8. That is, we are going to compare with 1 and 2. What is 1 and 2? This is the equation 1 and 2. Open circuit impedance parameter. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. So by comparing this, we can easily identify that. So both are voltage equation. We can compare this coefficient. Z11 is nothing but Y22 divided by del Y. Z12 minus Y12 by del Y. Similarly, Z21 is minus Y21 by del Y. Z22 is Y11 divided by del Y. So by comparing these two coefficients, both are same, both are voltage equations in terms of current. So these coefficients are compared. So that we are able to get this 4 equation, that is z parameter in terms of y parameter. Earlier y parameter in terms of z parameter we already got. Now we got the z parameter in terms of y parameter also. So in this video we discuss how to express z parameter in terms of y parameter in terms of z parameters. So by solving this equation and by comparing, we are able to identify the expression. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.